Nats.io community office hours. My name's Jeremy, and I have my guest with me, Nate, my co-host, Nate, joining us today, and we're going to be chatting all things Nats today. So if you are new here or you're just kind of coming in for the first time, we have these office hours usually on a weekly basis where we're going to be talking about all things Nats, maybe go over some news about the Nats community, and also take this opportunity to bring folks on, either from Synadia, folks who are maintaining the Nats project, as well as folks who are out there in the Nats community. And so welcome, everybody. Be sure to say hi and let us know where you're coming from, where you're hailing from. And again, feel free to ask questions. This is a place where you can have a Q&A. And I love to just, draw things. If you're used to seeing one of my videos, we try to kind of capture that in these office hours as well. Hey, David. Hey, Brian. Hey, Wayne. Thanks for joining us. And so today I'm going to go ahead and share my screen. We have a little bit of an agenda today, and hopefully we'll be able to bring on a community member as well and get your questions answered. So let's start off by pulling up my screen here. All right, so we're at office hours number 13. Don, who is now a member of the Synadia team, might be joining us sooner rather than later, hopefully, just talking about Nats and his update on his Lightshows. So if you remember kind of about maybe a couple months back, we had Don on to chat about how he's been using Nats to drive essentially these arrays of LEDs and a bunch of little, Raspberry Pi-like devices, via Nats for a kid's summer camp. So we might be able to get Dawn on. We'll have to see if we can, but the invite is sent out. Otherwise, we have a cool blog post that we want to read that's all about factory floors and driving factory floors via Nats. And then, of course, this will always kind of devolve into a Q&A, which I think is always great. So if you are joining us on chat, either via YouTube or another medium, you're here directly on Riverside, there are chats for you to kind of, jump in and join us whenever we can. So yeah, feel free to ask questions in the chat. I'll paste them here inside of Excalidraw, and we'll get to drawing and doing some other fun stuff. So just kind of as a prompting question, hey, what have you been using Nats for recently? And do you have any questions, regarding that particular project that we can go over and chat about? Again, we love kind of designing on the fly here. So I'm going to go ahead and get my Excalidraw going and start to answer some questions. But let's jump into this blog post about real-time analytics from edge to multiple factories with Nats and iFlow. So I'm going to go ahead and apologies if this isn't my normal setup. My desk is a little bit in disarray right now with my multimedia setup. So you have me on my laptop right now. So let me go ahead and pull up this blog post that we have, wherever it may be.
We do have a question from David in chat, if we want to tackle this before we jump into the blog post.
Oh yeah, why don't we do that? David asks, is it possible to observe the contents of a Nats work queue via the Nats CLI? For context, doing a Nats sub stream my work queue. Yeah, so one of the challenges with work queues is that simply subscribing to a work queue is going to start picking things off of that queue. And the idea of a work queue is something picks off the queue, acknowledges it, and then we're now safe to delete that particular message. And so in the case of a work queue, you might not want to inspect those messages directly, but rather you would want to kind of use the stream info calls for that. And so you can look at Nat stream info to see like how many items are in the queue, how many outstanding acknowledgements you might have in the case of that the consumer that's on that queue. But you wouldn't want to try to poke at those messages directly. That can be kind of an unsafe way of accessing that particular style of queue. There is something that we've kind of talked about for future versions of Nat server. They're not here yet, but this idea of more of an observer style consumer. So, it doesn't affect the whole work queue semantics of like, hey, when we want to delete those, but that isn't anything that's kind of baked in right now. And so, you can't really inspect the messages of your work queue unless you have them deleted. The other thing that you can do is and this, might not completely solve your issue either, but you can utilize the republish semantics inside of a stream. And so the idea here is we have a feature called republish for streams where you can say, hey, yeah, republish everything that goes into this stream onto another just like core Nats topic. So that can go into yet another stream, or it can go into some sort of monitor observer. And that's another way that you can kind of look at your work queue. But yeah, currently, whenever you acknowledge a message in a work queue, that message is going to get deleted. So something to kind of keep in mind. Yeah, and so David kind of follows up on that saying, yeah, I was thinking about along the lines of those observer consumer that wouldn't alter the state. Yep, it's absolutely something we've kind of talked about, but nothing that's necessarily in the server as far as I know at the moment. So, okay. If we don't have any other questions, I'm going to go ahead and jump in and grab this blog post. But let me
I did
go
have
ahead.
one more logistical. We're not live on Twitch right now. Was that intentional?
Oh, yeah, I ticked that one off
Okay,
because
cool.
I didn't have time to change my Twitch title.
No worries. I
So
just want to
yeah,
make sure that was understood.
yeah, so hopefully we don't lose too many people on the Twitch side of things. Um,
I think that's generally our least active chat. So yeah, I like that we've
yeah,
got a lot of the regulars are all in Riverside now, and that's helpful. Although it
awesome.
does aggregate most of the chats, but
Yeah, Riverside's doing a pretty good job here. All right, so let me go ahead and grab that latest Nats blog post. I had it up, but it looks like my tab must have gotten deleted. So give me one moment here. I'm going to pull it back up. Here we go. And then I'm going to go ahead and share my screen. Okay, so real-time analytics from edge to multiple factories with NATS and iFlow. So the one reason I really wanted to look at this blog post was this is a common use case that we see a lot of places, and I feel like factory floors is a really good way to chat about like why the edge is important. So beyond just like the idea of using NATS, like we have been seeing this trend at Synadia and of course people kind of using NATS, um, this trend of wanting to create a bit more autonomy inside of these kind of sites. So whether that site is like a retail store, or whether that site is like a factory floor, or electric vehicle charging station, or a parking garage. There's lots of kind of organizations that have these kind of multiple sites that they have to manage. Um, and figuring out the logistics of how you can kind of deploy, or how you can move data around, how things can talk to each other, both locally and globally. That's kind of a hard thing to figure out, and it's something I think Nats does really, really well. And so one of the reasons I want to talk through this blog post is because it kind of outlines some of the challenges and what it looks like to, bring real time to kind of a more like local, on-site thing. And so let's read through this and kind of chat about it a little bit. And I figured, Nate can jump in, share his thoughts as well, and we'll have a fun time walking through this. So let's start off in the competitive landscape of the manufacturing industry, in this case, automotive. Achieving efficient and scalable operations across multiple factory locations is critical. This case studies examines the implementation of a real-time analytics solution using NATS and iFlow to overcome common challenges such as data silos, real-time processing requirements, scalability, and communication inefficiencies in OT and IT environments. Primary design goal was to seamlessly scale real-time analytics across various factory locations. Yeah, we noticed this a lot too, how important it is for like for especially for analytics to be as real-time as possible on the floor. And the reason for this is actually really simple. Like you have this idea, and maybe I'm going to go back to drawing because I think this is actually pretty interesting. At least this piques my interest. Okay, so why is like real-time analytics important for this kind of like distributed multi-site kind of thing? Well, imagine for a second that we're like 5, 10 years in the past, where cloud is all the rage right now, and so you have the cloud over here, And everybody's telling you you need to move to cloud, you need to move to cloud, because cloud is where all the cool kids at. It's where everything needs to be. And so a lot of organizations moved their data, their microservices into the cloud, and they even built out like, their own real-time analytics pipeline to handle everything in the cloud, because the cloud was elastic, right? You didn't have to provision new hardware, like you didn't have to deal with like as much costing around, your growth or anything like that. It was honestly, for a lot of companies, it could have been more efficient, more cheap. Yeah, that's kind of debatable these days to move on to the cloud. The challenge is not all companies kind of fit in this cloud box. A lot of efficiencies of cloud came out of folks who are building mostly digital companies. But what about, what if you're a company that has more physical points of presence? Typically, you had to build out your own network and your own backbone back in the day, and cloud kind of provided a way for you not to have to do that, which was really good. But what we kind of lost along the way was we still had these physical sites, retail stores, factory floors, and we depended so much on the cloud to be able to get our work done there that it created some new problems, or maybe some possibly old problems that have come back to bite us. But that these factory floors are no longer autonomous. So if something in the cloud goes down, that can severely hamper the operation of that particular factory floor, retail location, et cetera. And so we're kind of seeing kind of a cycle back to maybe a healthier balance between, hey, what can be done locally versus what can be done globally. And it's not just about, is it up or is it down? Can things continue to run without being tied to the cloud? But it also, folks are starting to ask really critical questions around what should be done in the cloud and what should be done in a factory floor. Um, and this is really important, because sometimes, especially if you're going for real time, having to sync everything up to the cloud and processing everything in the cloud might not be it might not be like efficient. You might have just so much data that's generated here on the factory floor that it's just completely infeasible to try to aggregate all of this stuff in the cloud. So you need some sort of synthesis, right? You need some sort of way to be able to process the data and push up to the cloud what we feel like is important, um, but kind of either throw away or make local decisions um, with whatever else we have that we can't necessarily feasibly send up to the cloud. And this is kind of where we get at, where we have this idea of like, and I think this is just so important for the edge. One of the trends around edge is this idea of just localized decision making. And this is something we've seen a lot of when we've spoken with companies about, hey, what's important for you? What are you trying to do? And it's usually like, well, we have this like store and we want them to be able to, like especially in retail, let's say they have like global regional pricing, but then they also have like local pricing, right? Like imagine a grocery store where they have these like local prices that might affect a region or a state or a county, but then each and every store also has like stock they need to get rid of that they have to like price differently. And so this is like a common pattern, like beyond just computers. This is a common problem that exists in retail, is that you have this mix of global and local. If you're trying to, trombone everything up to the cloud, like that gets really, really challenging, and also just like not necessary in a lot of ways. So how do we like turn those retail locations, those factory floors, into places where it's way more efficient to just make real-time decisions with the data that you have on the spot, and you can mix and match that with more global data, but making these things more autonomous is super, super important from a locality perspective. And so that just kind of sets the context of why I'm like, okay, factory floors are really important for the edge, because it turns out like locality, geography, it all really matters here.
One aspect of this problem that's always intrigued me too is there's multiple scaling factors here, and one thing I didn't appreciate as much in the past is the scaling of messages and noise as well, especially when you're talking IoT and some of these devices. It's one thing to be at the edge because you have factories on opposite sides of the world, sometimes you have dozens of factories, but also a single sensor can generate so much data. I was introduced to a project, and I think it was like 10 or 15 drones and this NATS cluster that were able to generate like 15 million messages or something within the span of an hour. And I think that's something as well, that with a lot of these systems, there is so much density of data as well that it's not always feasible or desirable to, one, try to centralize that, or two, set up these kind of replicas to run analytics on at the same time, because it's just so burdensome. There's so
Yeah.
much information that needs to be maintained. It needs to go into the pipeline. But pairing up an analytics tool when you're pushing 15 million records an hour can get really crazy too.
Yeah, and that also kind of gets to the heart of a lot of these things, especially when people like reach for Kafka or reach for Nats, is they'll reach for them because they're generally like fast and they can process a lot of data, but there's still like an upper limit of what's feasible just in general, that you should be thinking about. Like, there's people who quite often will come to us being like, we need to collect all of this data, and what I'll often ask is like, are you sure you really need to? Because there's trade-offs with all of that,
Right.
and finding kind of that right balance of like, um, hey, where can you process this data so you don't have to just like push so much data through the pipes of the internet. So because often like good data synthesis is where you can get a lot of efficiency, and local processing is kind of where it starts. Like you said, Nate, there's so much data that comes out of a sensor, even to the point of like a lot of the APIs that you will use to grab sensor data, if you're just not like doing raw like reads on that serial bus or whatever it is, that is still like a synthesized version of it, even the very fine grained, control. And so, you should be thinking about your data as a way that how can we compress it into something that's like actionable for us. And a lot of times it just turns out like the data that we need for the factory floor, really only the factory floor needs it. So we might as well just make decisions there. Oh, looks like Don just requested to jump in, and he's actually a really cool person to talk about this with, because he's doing something very similar in this space, stuff at the edge. So we're gonna see if we can get him on board with his webcam and everything. Um, but yeah, I think this is just a really interesting topic to chat about in general. Even if you're working a complete just web scale, and you only have like one point of presence, like thinking critically about your data and how you process it and how you synthesize it into something that's actually useful, is important. And you don't have to think of trying to say, oh yeah, we'll collect all of the data first and then process it. Like that's the Google style, right? Just collect all of the data and then process it later. Um, we generate so much data now. I don't think that's like really feasible. You still have to synthesize it at some point. And so we'll see if Don can jump on. Looks
Yeah, while
like
he's getting the tech set up, I think something that this article hits on that's really cool is the use case as well. Is just so relevant with that real time decision making, because even if you can, like, let's say you had several data points, or several points of presence pushing out tons of data points, sometimes the decision that you want to be made, whether it's latency or data processing time, the time to make the change can pass before you've actually gotten enough of the data. And I think those centralized things, that's why the local decision making, especially if you're talking industrial equipment and factory floors, like sometimes they want to make real time adjustments throughout the day for efficiency. And it's literally like you would lose your window to make the best optimizations if you were waiting and saying, well, we're just throwing everything to buckets and having a Lambda kind of process things off of this as it comes in. You would
yeah,
literally miss the entire use case where the latency or the processing time could make your solution actually pointless.
totally. And I think we're getting close to what like real time actually means in a lot of ways. And I don't necessarily mean real real time, where we're doing rocket science and this thing needs to happen immediately. But I think we're getting closer to those benefits of real time decision making. Obviously, the things like, we've seen benefits in like trading and finance. Like that makes a lot of sense in our brains now, that it's like, oh, this is a market, and the faster you're able to execute and make decisions, like quite often the better. And so we've seen competition continue to rise there in real-time trading platforms. But like, there's a lot of shapes. There's a lot of like industries that have similar shapes, and that was kind of fun to learn. Like even for me to learn more about like folks who are using NATs in the like agriculture and food production industry. That like
Mm.
there's these like I don't know, like these butchering machines that can make cuts of meat, and like apparently there's a lot of different ways to slice up a cow to make certain cuts of meat, and meat's a commodities market. So it's like,
Mm.
rather than trying to have data processed somewhere in the cloud and then sent down and then maybe even have some sort of like you know technician like get the data, walk it over and change it a couple hours a day, or like every couple hours a day, um, if you could make that automated and real time as possible, um, you can really increase your margins. And so there's a lot of examples like that where real time decision making like makes a lot of sense, um, and being able to keep that kind of constraint to the factory floor. So we'll keep reading this article as Don gets set up, and hopefully we'll be able to get him on there. But curious for folks who are watching if you guys are running into any like edge cases like this, or if you've kind of if you've observed anything in the real world that you feel like could benefit from this real time decision making, because I love chatting about those kind of ideas. Okay, so there are several critical challenges that hinder operational efficiency and scalability through real-time analytics. First, there's data silo integration difficulties. Integrating data with disparate sources and systems is challenging, especially when dealing with a wide array of equipment and software. So you have like fragmented OT data, that's fragmented across various factory systems, leading to inconsistencies and difficulties in data management. Legacy systems, the presence of legacy systems further complicates the integration process, requiring customized solutions. So especially on a factory floor, there's just like a lot of different technologies for what it looks like to kind of measure and pull data from these sensors. And trying to get all of those working well together can be a challenge, it sounds like. No real-time processing. There is an urgent need for real-time data processing and analysis to optimize manufacturing operations. Delays in data availability hinders timely decision making, just like we just talked about, for operational adjustments. So especially critical on factory floors where you want to keep things moving. It makes a lot of sense. Integrate no scalability. Integrating operations includes thousands of machines and dozens of IT systems, increasing the volume of data, which I know we also just chatted about. Existing infrastructure struggle to manage this growth efficiently while maintaining the flexibility to adapt. Yep, this is something we've seen a lot of. And then lastly, unreliable communication. Ensuring reliable and effective communication between factory systems and enterprise applications is key. Today's fragmented OT and IT infrastructures across sites hinder seamless connectivity and real-time data processing. This is something I see come up a lot, and it's not just like legacy and factory floors and stuff like that, but it's like, and I try to harp on this a lot. This idea of like, you distributed systems don't necessarily. I mean, of course, the field of distributed systems is all about distributed computing, in general. But one thing to think about with NATS is like it solves distribution challenges, not just in the pure distributed computing space, but also in like an organizational level of distribution. And this number four, I feel like, hits on this home, or hits this home, is like this idea of we might have sprawl in the form of all of these different business units that like have their own technology stacks that all need to communicate with each other, and like that's an opportunity to like streamline communication as well. And it's one of the reasons I feel like we designed NATS to be like this public utility inside of an organization, where you like have this one big NATS cluster, NATS system, and everybody can connect into it. It might be different tenants or on different accounts, but like the idea is that there's like one streamlined way to like share data between those teams. Um, and so there's no longer an integration cost. Um, and that's the general idea. And so whether you're trying to hook a factory floor up to the cloud, or a factory floor up to another factory floor and share that data between them, or you're just trying to get two different business units to talk with each other. I think that's one of the beauties of something like NATS, is that it solves not only just the hard distributed computing problems of consensus and clustering and global scale, but it also solves that for like an organization, And I think it's important to try to get those two things clear, where it's like you could still be still in the cloud, but also like running into problems of distribution. If your organization grows too big, you have too many microservices, too many tech stacks to try to wrangle and integrate. So that's something to also think through. Okay, so what's the solution? NAT serves as edge and enterprise level messaging system, ensuring seamless and reliable communication across all levels of the organization. iFlow functions as the connectivity, harmonization, and NAT's publishing layer for OT data. Oh, that's super cool. Effectively integrating and standardizing data from various sources before publishing it to NATs for real-time processing and analysis. Okay, so for this use case, for factory floors, why NATs? Let me try to get Dawn on one
Let's.
more time. Oh, there we
Hey,
go.
now we can see Don.
Don, you made
Can you
it.
not also hear me? Oh
Yeah, we
Yes.
can
yeah,
hear you.
yeah, cool. Yeah,
Welcome
I
to the
was
show.
I was hearing you talk about like, yeah, now we can do real time and stuff like that. Um, so yeah,
I know. I
it's
was like, this is a perfect
pretty cool,
opportunity to get Don
pretty cool.
on. Yeah. So what do you
Yeah,
got going on?
yeah,
You're at
yeah,
the summer camp right now, right?
yeah. So we have been building everything up for the last 2 days. Um, so basically, there's no mobile connection whatsoever. There isn't Wi-Fi, anything. So we have to bring everything ourselves. We pulled in like fiber connections.
Oh
Um,
man.
basically, like literally everything needs to be brought here. There's no power. We have our own power grid here that has been
Oh my
set up.
gosh.
Like you can see in the background. You can see in the background these lights.
Mhm.
There are approximate like 84 towers is basically illuminated. And the nice thing is that the stuff that is running behind me, these lights, these are actually running on something called DMX, which is a
Mhm.
lighting protocol, but we implemented that on top of NUTs. So all the lights are basically running our microcontrollers that we designed ourselves, written in firmware that we've written ourselves, and are communicating with a NUT server that's sitting here on-prem, and that we can communicate with and basically all devices. We even have for every participant. Let's see if I can take it out. I hope I have the right one with me. No, I haven't. Um, we have electronic, and each of them have this little electronics badge that communicates over nuts as well. So it's basically it's geek heaven, I would say.
That is so cool. I love it. Yeah, I love the crossover of NATs and just general like IoT hacker community stuff. And I know Nate and I have chatted about like
Yeah.
we just need to do more of that. Like for office hours to do more videos because it is a really cool fit. And there's a lot of neat things that you can do with it.
Yeah, it's actually a no-brainer, right? The thing many people start especially when there's
Oh man, it looks like we just lost Don a little bit. Hopefully we can get him back.
start playing around with IoT or yes, I'm back. No, I'm
Yeah, you might want to turn off
not
your video
back.
and you might get a little bit more bandwidth, but
I'm back. Can't turn it off, it seems.
yeah, let's see. All right, let's see if we can hear Don a bit better with just audio.
He did mute audio as well. I don't know if that was intentional.
Oh yeah, let's see if we can pull him back up. Don, are you there? If so, you are muted on audio. All right, well hopefully we'll get him back sooner rather than later. But let's jump back over to that use case on real time analytics. Okay, so high throughput NATs is capable of handling high volumes of data, which we just talked about, which is essential for scaling operations across multiple factory locations. This high throughput capability supports increased data demands as more machines and more systems are integrated. Reliable communication, NATs ensures reliable communication between different components of the manufacturing system across all enterprise levels. This reliability is vital for maintaining seamless operation. The architecture of NATs allows for easy scalability, accommodating the growth of companies' manufacturing operations as new factories and use cases are added. NATs can integrate them into the existing system without significant reconfiguration. And then lastly, it's 100% deployed. On-premise NATs is easy to deploy and scale with the need for black box cloud-based services. This provides maximum confidentiality to the end user. Yeah, this is a really cool thing as well, is this idea of giving kind of more black box properties by by just deploying as much as you can on-prem. And this is I know huge, especially for folks who might be offering like services or companies that are just part of the manufacturing process, one part of the manufacturing process, and they're able to offer like a service to like a company who has a bunch of factory floors, things like that. Um, I was actually just talking to an old coworker of mine too, where they don't use NATs, but they work in this. They work in a very kind of like similar edge space, and they built out a lot of their own tech. But similar to what Don was just talking about, like built out their own microcontrollers and then kind of a software control layer on top of that, and interfaced with all of that. And I think this was like in the energy space. So like being able to kind of monitor and the power grid, I think, is just crazy, right? Like the fact that the power grid is its own market. And so back to us just 5 minutes ago talking about real-time markets, whether it's a commodities market like meat, or whether it's like the stock market. But then we have a market in energy as well, where the power grid provides energy, but also buys energy from people. Not only that, but they will actually, at least here in California, we are kind of in a continued energy crisis, right? And there's a lot of the energy companies will also negotiate with high energy users, usually not residential. It's usually factory floors, distribution centers, stuff like that. We'll negotiate, off times for them, so that they can prevent brownouts or blackouts inside of the power grid. And so they even build things at the edge to help monitor that and to help make those negotiations in more real time. And I find that really, really fascinating. And just another example of, hey, there's companies that are providing this value to either the energy companies or the companies that are partnering with the energy companies in order to like make a maintainable power grid. But maybe confidentiality is super, super important. So how do you have as much of that, much of that decision making happen on the factory floor where it's confidential, synthesizing that information to something that's less private and more usable, so that like the company upstream can make those decisions better. So I think that's like a really cool use case as well. We're starting to see a lot of trends around, there are these little markets that exist where real-time decision making is so critical. Okay. And Don, feel free to interrupt if you if you do happen to get back on, but no worries either way. Implementation steps. So OT connectivity with iFlow. iFlow is deployed at the factory edge level to provide bidirectional connectivity for real-time data exchange and integration between NATs and other various OT systems. This includes SCADA systems, PLCs, MES sensors, all different protocols and implementations for certain factory devices and sensors and things like that. And I know we have a couple videos on SCADA. David G has done a ton of work in working in the SCADA space, and I think he has a couple videos and podcasts that we have online where we talk a little bit more about that. Yeah, Nate, we'll have to bring David on to talk about maybe some of the SCADA system stuff in the future. I think that'd be fun.
Yeah, I'll note that down. I also just had Don reached out to me, and the connection is just too unstable right now. So we'll try to get him on next week for a recap, maybe, of the camp setup.
Maybe Don, if you're listening to this, or we'll just ping you. Maybe we make a little video and we share that on office hours or something like that. That'd be super fun.
That would be very fun. Yeah, you said next week we'll make it up to us by showing how all of it worked with some nice pictures.
Oh,
So
love it, love it. Yeah, we can do a retrospective episode on that. That'd be awesome. Okay, publishing and subscribing data with iFlow. So iFlow publishes harmonized. I imagine harmonized just means kind of like synthesized, or getting it in the aggregated OT data to NATs, enabling real-time data streaming from OT systems to enterprise applications. Additionally, iFlow subscribes data from NATs, facilitating bidirectional communication between OT systems and enterprise level applications. This is so cool. So basically, like, it seems like they built a bridge between, like, iFlow kind of acts as this bridge between NATs and these, like, these various like system factory floor devices, which is great because it not only means that these enterprise applications are able to consume data that's produced on the factory floor, but they're also able to drive these machines as well, which is ultimately what you want, right? You want just this one protocol to be able to control and do all this stuff. And so if you're putting everything through one pipe, sure, you have to build some of the bridge and those initial integrations, but once you're done with that, integrating in the future is so much easier. And the cool thing about NATs with this is, like, as opposed to, like, let's say an alternative universe where everybody says, well, let's just put it all on Kafka because, like, that's what a lot of people say. The problem is Kafka is a pretty heavy operational burden and operational lift for a lot of organizations. And so the idea of, one, like, deploying it in just the cloud is already an operational burden, but then trying to, like, deploy it on all these factory floors
all
is
the
another
premises.
challenge. And
Yeah.
so ultimately they, like, reach for, like, yet another protocol, and now you have this problem where you have all of these integration points across the entire system. That's really challenging. And so if you're going to have to integrate, like, it might be good to try to integrate at that last mile, right, at that factory floor level where you have all those protocols, and then from the factory floor and the applications that live there all the way up to maybe even a regional control center, then to the cloud, you have just a single protocol. And I think that makes a lot more sense to go about it that way instead of, like, duct taping a dozen technologies together. So that's pretty cool to hear. Nat should run Starlink is what Steve says, and Brian jokes about the idea of doing Nats over Starlink. Yeah, it hasn't been lost on us. I think Derek would really love to do something with Starlink someday.
I mean, we could
Okay.
already do some stuff with it, just leveraging the internet, but that's kind of double dipping. Having that protocol level integration would be
Yeah, I
pretty
think
pretty
they want
incredible.
Starlink nodes to, like, communicate with each other over NATs, which that would actually be pretty dope. Um, Okay, edge and enterprise level data processing with NATs. So it looks like what they use NATs messaging. So NATs acts as the messaging backbone, providing low latency, high throughput messaging capabilities. It ensures reliable communication between different components and manufacturing system across all enterprise level. Real-time monitoring. So enterprise applications subscribe to topics on NATs on real-time updates from the factory floor, which is super cool because not only are you able to collect all this data, but you're able to respond to it, and then analytics and reporting. So they synthesize the data, they push it up to the cloud, the stuff that's relevant, and then they can use that to re-optimize the production process, which is super super cool. And so this is, I guess, a little preview of what the architecture looks like here. So they have two factory floors. They have a NAS cluster in the cloud, and that's going through each of these is punching through a firewall, and yeah, so they have a bunch of microservices in the cloud, and then they use kind of this bridge to put this on a NAS leaf node. But the cool part about it is, like, in this case, they have, like, a lot of their microservices running in the cloud, but nothing really stops you from saying, hey, we have this microservice that's running over here, and, like, the latency between this thing receiving something and then making a decision about it back on the factory floor is just, like, it's too high. And so, like, why don't we just, like, take these and deploy them in each of our factory floors? Because most of the relevance around its decision making might just be completely local. That way, you get more real time responsiveness. You don't have to be reliant on the cloud for it. And the cool thing about all this is, like, you don't have to really change configuration, and you could even, like, just move it back. Like, it's not a lot of effort to do either of those things. as long as you have kind of the deployment capabilities to do it. But it kind of speaks to this idea, and we've been harping on this for a long time, this idea of like nomadic applications. You have apps that are truly nomadic. They could live in the cloud, they could live on the factory floor, and they can still communicate with everything without changing its code, its configuration, or how it works. And that cannot be, I don't think that can be overstated, because it's a really huge benefit, but it can take a little bit of time to really catch on to like, oh, this is actually super valuable. All right, let's continue. An implementation of NATS and iFlow brings significant benefits to customers and improves key aspects of their digital infrastructure. So they get improved efficiency, real-time data integration and processing. They get enhanced data visibility. So they do have like this centralized data, which is great because they don't have to pull data from these factory floors. They're just like data's pushed to the cloud. And even when internet goes out at a particular factory location, all that stuff is stored and then forwarded onto the cloud when they need to, which is great. A cost saving. So this is something I don't typically like jump into of like, oh yeah, how much cost savings does it make? But like what we hear from customers is that it does end up being cheaper. But I want to read through this. So significant cost savings and increased productivity through real-time insights, resulting in reduced downtime and faster decision making. Reduced data and system integration costs. The seamless integration of OT and IT systems through iFlow and NATS reduce the time and resources required for data and system integration. I think this might be what it really is it sounds like they have like a team that kind of solve that integration layer like we were talking about at the last mile, so that the idea of integration is like no longer like a challenge that spans multiple teams, multiple organizations. It's really like, hey, let's get everybody on the NATS train, and then integration is like no longer a problem. Obviously easier said than done, but
it removes the need for ad hoc integration, though. I was curious in the first bit of this paragraph. It's kind of like, wait, he's not even necessarily talking about cost savings with implementation, which second sentence maybe getting more into. But again, the flexibility as you continue building out the system. Every new piece, you would be doing some kind of ad hoc integration. And that's why I think the power of NATS at this network and messaging layer of unifying all that and just having the SDKs for either end of it. Because it's bidirectional, whether you're consuming on one end or whether you're pushing more into it via a different client, that whole integration layer problem is just going to be solved for you.
Yeah. I love that framing. The ad hoc integration is really the cost that probably bites people the most. And so people kind of thinking ahead, and it's not like NATS is this magical piece of software that just like, is the only thing that can solve this. Like you can solve this in a lot of ways, but I think NATS kind of does a better job forcing you down that path of like, oh yeah, we can consolidate a lot here and do some last mile integration of the things that like, is important to our business, but might not be, on NATS radar, like OT systems. And then, then you kind of have that single layer that everybody can jump on the bandwagon with. And like you mentioned, Nate, like the multiple SDKs, the multiple language support, support for older tech stacks, and even support for very old operating systems. In the case of the NAT server, I think can really like help with those integration costs as well.
And I think the cool thing with NATS, again, somebody coming with less of a IoT kind of distributed, devices embedded programming background, it's consolidation at sort of two levels. You have a consolidation at the technical level, at the data level of protocols, the way we communicate, the way we describe our data. But then you also have kind of conceptual consolidation where NATS pushes you into certain patterns and use cases, even just the configuration options that are available on your Jetstream instances and how you configure those things. I feel like the usage of NATS results in so many questions being answered, both at the technical, like we need to integrate this additional system, but also just in how you discuss and architect the distributed system itself. It's kind of like, well, NATS is giving us these configurations out of the box, and I see the levers I can pull. I see those things, and it just kind of locks you into remove some of the ambiguity in building these systems, I guess. It's going to give you a few of these best practices and bits of success along the way.
Yeah. And I've talked about this for a long time. It's like NATS offers this kind of toolbox for you of things that you'd normally have to like make make kind of like a provisioning decision about, like, hey, do we want to adopt Redis for this, or do we want to like
Right.
adopt, S3 for our object store? Do we want to use something like MinIO? Like, and of course, you can still make those decisions based off of like whatever best of breed or feature you want. And maybe Nats doesn't fit for everything, but it certainly gives you like a nice like toy box of things to kind of pick off and have confidence. One, that thing is already running. Two, you know how to secure it and you have a unified security model for it. And three, you already have like the SDKs for it if you're using Nats. And so there is a huge benefit, and it probably is one of those sleeper benefits too that people don't realize until they start really moving and grooving with Nats. But like that, yeah, like removing the burden of that, having to make those technological decisions and across a lot of the organization, makes it so nice, like so nice, because it does really solve a outsized portion of distributed systems problems in general, by using those tools. Um, okay, we did get a question from Hrithik on Synadia Cloud. So he said, I was wondering, does the user management on Synadia Cloud use decentralized auth under the hood? This is a great question. And the answer is yes. And so, and one of the reasons behind that, I'm going to just draw for a second because I think it's a great question. And we'll continue on with our video. Just share my drawing. So yes, short answer is yes, absolutely. We use decentralized auth under the hood. But the reason for that is there's a couple different ways you can do auth in Nats. And there's a bunch of different like ways you could do the actual authentication bits of like how people get authenticated. But I want to separate these out into two camps at a higher level of basically how do you tell the server to start authorizing and what to authorize. And we really have a couple high level ones, which is like you have your config based auth, which means you have to configure, set some sort of configuration in the server every time you want to kind of modify that authorization system. This could be anything from like, hey, we're setting up TLS, so like, or MTLS, and how do we want to set that up? How do we want to configure it? To here's the N keys, to here's the username and password. Like there's a lot of different things that you could set up in config based auth, but at the end of the day, it is kind of all the same. Like a lot of the configuration for that auth and what you choose to accept and what paradigms you use is all kind of based on the Nats config inside of the server. Then we have decentralized, which still uses, there is still a little bit of configuration, but the whole point of decentralized is that you can kind of configure those servers really once, like just set them up. And then everything else is driven in a more decentralized manner. And I have a whole video where I talk about what decentralized auth is, that you can kind of go into all of the deep details. But I wanted to kind of just outline the problem with config-based auth. Is config-based auth can be really simple, and a lot of people kind of start with it. But it gets harder as you have a more distributed system. And in the case of Synadia Cloud, which is built on top of a global supercluster we call NGS, decentralized auth was really the only real feasible way to go about it, because we have this multi-tenant system where we have, not only do we have like a bunch of users on that system, like your own client credentials, your own clients connecting in, but we also have like somebody who's signing up, acting as a tenant of that system. And we want to isolate, between all of those tenants. And so you can configure all that stuff in a config-based auth, but it means every time you want to add a user, we would need to update the config of every single NAT server in that system, like every single NAT server. So that's all servers across all of these different, geographies, all these different clusters. We have to update and propagate that config for all of those. So it's just like, it's simply not as feasible to do a config-based auth in that manner. And so that's where we reach for decentralized, where the model is a lot more palatable. Palatable, yeah. where you have this idea of like a NATS cluster. And really all that you configure is a couple things. You configure like you configure a operator, which is basically just a identity of like, here's the person who has kind of the master keys. Here's what they represent. So in our case, like Synadia is the operator of NGS or Synadia Cloud, right? And then underneath those operators, you have, you know, accounts and users. And so accounts kind of act as those tenants, which could be like you, Nate, or me, or my company, or my organization, or my team. And then users are those client applications that exist here. But the cool part about this whole decentralized auth is it's really like this delegative flow, right? Where Synadia, the operator, delegates. I want to see how I want to draw this. Synadia delegates all of the user stuff to the various accounts, and it kind of goes down that way, which is kind of nice because it means users have a degree of autonomy, how many connections they can create, what their general limits are, and that's set by the accounts, which have the autonomy to create users. Like they don't have to ask Synadia permission to like create new users or to, you know, create new jet streams or whatever, like anything like that. But then Synadia has obviously its own degree of autonomy where it can say, hey, I'm setting up this account, I'm, you know, signing off on it, and it has these particular permissions. So it's not simply just decentralized for decentralized sake, but it's creating this kind of delegative pattern. And it's really the only way that something like Synadia Cloud could work, where we're having these multiple entities that are like coexisting inside of the system that want to, you know, be autonomous in some sort of way, create, you know, or be delegated an amount of responsibility, like creating my own users, creating my own jet streams, etc. So I know it's a simple question, is it using decentralized auth under the hood? And the simple answer is yes, it is. The more complex or long-winded answer is it needs to. And I'd recommend that lots of people, even though it feels a bit more complicated, try to reach for that decentralized auth because it just sets you up for a lot more organizational success. We've seen far too often that, and again, this goes back to our toy box analogy of like, Nats gives you all of these fun toys to play with. And what we usually see is like you use Nats for like one thing and you go like move mountains inside of your org, and now people are paying attention. They're like, we want to use it for this and we want to use it for that. And this team wants to use it and that team wants to use it. And like then we start seeing the team that founding team that started the Nats, you know, use case is now overburdened trying to get more teams onto Nats, trying to figure out how to wrestle with these multiple teams working with Nats in various ways. Some are using Jetstream, some are using Core Nats, some are using you know, object stores or KVs, some are using the distributed nature of it, some are not. Like, how do you wrestle and wrangle with all of that organizational complexity? And our answer to that was kind of the decentralized auth model, where you can delegate a lot of the responsibilities so that you don't have to be that one bottleneck as a team. And so it is a bit more enterprisey in that way, I guess. Maybe your use case for Nats is that you're only connecting a couple clients and those are fairly static, they don't grow or anything like that, then you could totally use config-based auth. But when you get more servers and you get more clients and you get more kind of shapes of tenants, you get more teams using it, the decentralized auth really, really pays off well, in my opinion.
So we got two quick follow-ups from Horrific. First, how much overhead is there in provisioning and deleting a user in Synadia Cloud? And then second, is it possible to create accounts using the Synadia Cloud API?
Great question. So, and easy ones to answer. How much overhead is there in provisioning and deleting a user in Synadia Cloud? Not a lot of overhead at all. We do store it in a database, but we don't have to touch a NAT server for it. And that's the beauty of it, is accounts can create users cryptographically. Now, we store it in a database so that you can see it in the UI and you can download it and stuff like that. But other than that, it's like little to no overhead. We don't touch a NAT server at all, so it doesn't affect the NAT system at all in order to create a user. And the second one, can we use it using the Synadia Cloud API? And the answer is yes, absolutely. And we actually built it with that in mind. So everything you could do in the Synadia Cloud UI is available as a REST API. If you go to the top right corner, of Synadia Cloud, you can access the API documentation. And we have everything for you. So creating a user, creating a group, all that stuff can be programmatically done. And I also know that the team has scoped, I don't know when it's coming, but has scoped for bringing in more like infrastructure as code tooling to that process. So if you want to use like Terraform or whatever to provision that stuff, you totally can. But we encourage you, like if you have a system where you want to dynamically create users, we might not bake it into the UI or make it a feature of like dynamically creating users, but we'll give you the API and you can execute it that way. And that way you do have kind of a more safe, accessible space for your teams to be able to express patterns like that without it falling on the standard decentralized auth model, which is like using NSC, and now you're creating a bunch of shell scripts to try to do that stuff, or you're just building your own generalized system for it. It's a much easier developer experience, in my opinion.
And we've got about 5 minutes left. Maybe we can close out with Brian's question above.
Yeah, let's close out with Brian's question. Brian asks, how does NAT server handle a client that lost network connectivity, but somehow the socket wasn't closed? Can it detect the failure? Does NATS expect an ACK from the client on delivery of messages? Yeah. So yes. So the client protocol does have just a lightweight kind of ping pong mechanism to kind of detect clients' liveness and heartbeats and things like that over the TCP socket. So if that doesn't work, there's a timeout that the NAT server will then just throw away that socket connection, and the client, upon that socket being terminated, will then go ahead and retry. So there's logic on both sides that tries to kind of handle like a reconnect in that case. There's always different ways that networks can throw a wrench in things, but I believe both the client and the server tries to do a pretty admirable job of trying to reconnect to the server, throw away whatever stale connections might live on, and so yeah, that's absolutely something that's built into both. Great. Well, I think that is about time for us. Unless we got one more question from David. Follow up to Brian's great question. Is there substantial benefit if clients connect to all instances in a NAS cluster in terms of load distribution, reconnections, etc., or using a single proxy good enough? So here's the thing. Yeah. So, and it gets a little bit tricky when you're using a proxy, like a Kubernetes like service, or even like a load balancer. What you'll want to do is you'll want to make sure, this generally happens out of the box, with NATS, but it's worth checking in with your Kubernetes, setup. That servers are advertising, their connection, their addresses. That's a configuration you can set inside of NAT server config. And the reason for that being is that when you connect to a NAT server inside of a cluster, that server will actually return a list of its peers back to the client. And so if a client gets disconnected from the server, it's going to, pick from one of those peers to try to reconnect to. And that's really important from, a perspective of like, hey, we had all these clients that were connected to server A and server A went down. Where did they go? And typically you would have a load balancer kind of manage that for you. But we actually do, that inverse, that typical client side load balancing, where clients can then decide, oh, I'm just going to move over to a peer of that, and it's a little bit faster in that way. And so that kind of exists out of the box. Clients will reconnect. Clients also get gossiped, peers about the servers, and it's all dynamic too. So if you have like servers that are coming up and coming down, that gossip protocol works in that way. So I would just double check your Kubernetes setup there. And make sure that you're not blocking any sort of like direct connections to servers. I still recommend each server has its own connectable address so that things can be gossiped and clients can then, reasonably connect to that server directly. It really helps with a lot of the load balancing dynamics there. Great question. Brian, as a follow-up to his own question, says, my concern during that time that the client is assumed connected but is not, that messages sent to that client can be dropped. Pings and timeouts are eventually consistent, but during that time of uncertainty, what happens? Yeah, so we do a little bit of buffering in case of like network jitter. But the reality of it is, if you have stale connections that end up being held onto for a long time, again, we have pings and pongs that try to, you know, work around this and detect stale connections and try to reconnect. But like if you're going over core NATs, you just have to assume that like messages can be lost. Um, Things can go offline, connections can become stale or broken. And in that case, if you need that guaranteed delivery of messages, that's when you reach for something like Jetstream. Yep. So, I mean, there is buffering that is happening a little bit, but that's in the case of like general network jitter and not necessarily like super stale connections or anything like that. And that about does it for our stream. Thanks everybody who hopped on and asked some questions. There were some good ones that came up, and hopefully next week we'll have Don online to join us and chat about his Nats light show and how he got all that going, or at least share some pictures and stuff. But yeah, thanks for jumping in and asking questions. It's always fun to chat more about Nats with y'all. So we will see you next Thursday, same time. All right. Bye,
Take it
everybody.
easy.